Yeah, okay, great. We're rolling. This will not take long, my friends. This will be quick and painless. Today is September the 8th, and we're going to start today. This will take this concept called multiplying polynomials will take today and probably at least one more day next week because we want to be multiplying. Sorry, I started talking and then I just quit writing. This will take a few days. This is something that is pretty non-negotiably important, kind of a fundamental piece of a lot of this mathy stuff. So nothing to it. I'm not going to start you in the order that I normally do. I would normally start with the simpler and work my way up. I'm going to go ahead with you guys and start with the longer problems so that we can scaffold back down next week. So we'll get these longer ones out of the way today. If we multiply two polynomials together, that can mean a lot of different things. I think most of the ones that you're going to see today are going to be binomials times trinomials, for the record. So now that we're familiar with what that terminology means, we understand that there'll be two things in a set of parentheses multiplying by something with three things in another set of parentheses. And really what this comes down to, again, and not to joke about what Colby said, the little mistakes will kill us. I mean, it's so if we're saying things like, because today is all multiplying, it's all multiplying basics. And if we say things like 3 times -2 is 6, gone, done. Yeah, wasting our time. So today, each problem is going to have a ton of multiplication distribution that we have to do. It all has to go perfect. There's, it's not like English or other classes where you can make little mistakes and have massive success. Math does just, bless you, math just doesn't work that way. So here's an example of what our problems are going to look like. I trust, because you've all taken the Algebra 1 class, and so you've seen this before, like you've had to do this before. Let me ask you a question to see if you kind of generally know where to go. How many multiplication problems have to go well for us to get through step 1? No. How many means like a number. How many multiplication problems? That's the answer that I'm looking for. There are exactly 6 multiplications that have to take place. And really what it comes down to is this is just like the distributive property, distribution buffed up on steroids. And so what's happening here is I have to take and multiply everyone from the binomial or the first polynomial by everyone in the second polynomial. The worst thing you can do is lack organization. So I'll teach you what I believe is the most organized way to do this. Now, whether or not we make small mistakes, that's outside of my control. Here we go. The first member of the first polynomial is 3x, and I'm going to circle that, and I'm going to use red so that the next things that I draw in red will make perfect sense to you. Okay? We're going to be rocking about 90 degrees in here by about 1 o'clock. Yeah. 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 So, yeah. It's tough. It makes the job hard. So, for all of us. It's exactly how I expected that would go. You see the chuckle? Did you see the chuckle? Like this is a game. I should just stop now. I want to say it so bad. And I am not going to say it right now, but I just felt some serious rage. And I'm just going to take the high adult road and I'm going to keep talking about polynomials. And now I have to edit my video. Gosh darn it. I didn't. Did I say any dirty words? Nice. Then maybe I can keep it in. Let's be real indeed. So back to math before my concerns were dismissed. I have a red 3x, and what his job is to distribute to everybody. Obviously, you don't want to distribute him to the -4, because 4 is like in the same batch. And so we're going to take 3x, you've seen this before, and we're going to go multiply, multiply, multiply. I certainly don't expect that every time you do one of these that you'll draw arrows, but I will because I'm doing my job to the best of my ability. Those arrows for me are a real visual representation of what it means to distribute. It's like you fly over, dropping cargo along every point that you need. Yeah.
So exponents are not
Exponents will be affected now. I don't know. We'll add the exponents together, right? So, and this helps that your intermediate algebra say so. A lot of the basic algebra you already just know, and you forget some things along the way. But like when I remind you of this in a second, you'll all be like, "Oh yeah, I remember this." So when I take this 3, the distributor, and I multiply him to the -4, I'm going to wind up with
-12.
God. So when we take the distributor, the 3x, and we multiply it to the -4, like Colby said, we are just going to multiply the 3 and the -4. And that, of course, is -12. Now, this is the only little algebra-y part of this lesson is how many x's are there going to be when I'm done? There's going to be 3 because the multiplier has 1 that you can't see, and the recipient has 2 for a grand total of 3. Couldn't have said it better myself. And it's weird because even though we are doing a multiplication problem, we add exponents to make it work, right? Yeah, man.
So the next one will be
absolutely perfect. So as that 3x continues its flyover, it just keeps multiplying by everybody one thing at a time. And you can see it's a slippery slope. Like maybe that's not the right word, but like one mistake and everything we're about to do is gone. So there are 6 multiplication problems that have to go perfect. And then it'll feel like last night's homework after that because we're going to be combining like terms. So anyways, like Colby said, 3x times -10x is negative. So I'll just put minus 30. And then the x's, like Hawes said, there's 1x here, 1x here for a net total of 2. Add them up. And what's my last product going to be? Yeah, and it's going to be positive because it's a +3 and a +5, which makes a +15x. Good so far?
Mm-hmm.
Nice. Okay, and this is the one you got to be a little, scared isn't the right word, but give the next part some respect. This is where all the mistakes happen. So what's happening now is the next distributor, when I ask people what's the next distributor, they sometimes say 4, and that's where we get into real trouble. Who is next?
-1.
Yeah, and so the guy up here with the fake pen isn't going to circle it and call it a 4. I'm going to very carefully highlight that it is a -4. And why do we care? It changes everything. I like the way you said that. Some people say, well, it makes everything negative. And I go, don't think, no, it changes everything. And so like the King Midas, everything you touch turns to gold. This just, everything it touches flips, flip, flip, right? And that can mean a couple different things. So the first distribution occurs right here. What is the answer to that?
+16.
Nice. And I want you to notice that as I show my work, I'm going to put it like this. You certainly don't have to. I started doing it this way like, I don't know, 4 or 5 years ago. I think it's pretty cool. What it does is it's going to help me now when I go to do the last step. My like terms are already going to be lined up.
Wait, how did
I'm writing it down below rather than putting it over here. These 3, I'm doing, those red things have nothing. Yeah, those are just waiting to be added to by now the answers to the yellow things.
Can we add to the right side if it just...
Oh yeah, but yeah, if me writing it like this is bothering you, then
So can we just put plus after the x?
Just put plus 16x². I don't really care. I'm just trying to show you a different way to show your work.
I'm just confused.
I'll show you right now. You see this yellow arrow right here?
Yeah.
Okay, that's -4 right here, multiplying by -4x². He's basically doing the same thing his buddy did. I heard that light bulb. Come on, good. So what's happening is that multiplier is now just going to follow his buddy's trend. He's going to just do the same cargo drops, right? Winslow, you okay now?
Yeah.
Okay, good. And now the -4 is going to fly over to here. The arrows start to get a little chaotic here, and we get +40x. And then the -4 is going to do a flyover to the 5, and we get good. So the only reason I feel like I can do this now, because maybe there's a little less confusion, when I do this I don't know if I got everything I wanted, but yeah, I show my work like this just because now that you're not confused, it makes more sense to do it this way because then I don't have to go track down like terms. They're already by each other. You follow? So now when I want to go find the answer, I just have to go straight down and hope I don't, say or, mess up, do anything stupid. So when we add straight down, here comes some answers now. What's our leading term? Yeah. And then what's our quadratic term? That's going to be right down here. Add straight down the blue arrow, guys. What do you get? It is -14. And then we just keep the x squareds the same. When we add terms together, you know this from last night's homework, we don't change what they are. We just change how many of them there are. So like some x squareds plus some x squareds, they don't change into x to the fourth. They're just a different number of x squareds, right?
Yeah.
We only tinker with exponents when we're multiplying or dividing. If you add down the next column, the linear column, that's going to be, yep, positive, so plus 55 x's. And then you add down the constant column. There's really nothing. There's never going to be any math to do over here and over here. Those terms are always going to be singletons. I got nobody to go with, so you just copy it down and you're done. And these problems can get longer. Did that make sense, by the way? Yeah, sure. Who said that?
How can you get combining all of?
Because they're not like terms. I mean, it's like number 2, I think, on the 10 commandments of mathematics. Number 1, thou shalt not divide by 0. I think number 2 is thou shalt not combine unlike terms. I think.
I understand that.
Oh. Because the definition of like terms is terms that have the same variables with the same exponents. So like x can't add to x squared. They're not the same. They're totally different entities. It's okay. It's all good. Now you know. All right, let's try a longer one. Now that you know what you're doing. So we're going to do a simple, like a quadratic trinomial. We'll do 2x squared minus 5x minus 1 times 3x squared plus x minus 8. So Sam answered this question last time. I'd like it if someone else answers it this time. How many multiplication problems is it going to take for us to get through step 1? Say it again. 9. Yeah, I look at it like there's 3 worker bees that are in the first parentheses, and each worker bee has 3 jobs to do. Like 2x squared is a worker bee. So I'm going to circle him, and he sets out for his workday, and he says, okay, here I am, one of 3 employees reporting to do my 1, 2, 3 jobs. It's just a patient process. All right, let's get to it. I'll write these in red. What's my first product? Perfect. 6x to the 4th power. Nice job. How about my second product? Very good. So plus 2x to the 3rd. And my last product? That's it. So we can say, hey, thank you, Mr. Red Worker Bee, for your service. You're no longer needed for the day. You can head on home. And next up is the second worker bee, who is negative 5x. And he'll do the same thing. So he's going to go job, job, job. What's the first one? Negative 15x to the 3rd. And I'm going to choose to put it underneath the other x to the 3rd just because they're going to go together later. Why not put them together now? What's his second product? And the last one? Yeah, and it happens quickly just like that. And what sucks about these is these problems take several minutes to complete, and you just do one little thing like forget a negative or a positive, and everything is for nothing. It's like nothing. So unforgiving, right? -5, -8, positive 40. And now the yellow worker bee has done his jobs, and it's time for, we'll say, the blue. So blue's up to bat now. And blue says, got a job, and a job. It's getting a little hectic up here. So what's the first one? And I'm going to put it underneath the other x squareds. And then minus x. And then the last one is positive, so plus 8. I couldn't possibly think of a better way to do this than to line them up this way. I was pretty resistant to it for a long time, and really looking back, I don't know why. It makes perfect sense to show your work like this. No reason not to. Kind of sometimes I feel like people could say, well, I like to do it this way. And okay, I'll support that. I don't think in this case that I would. This just makes sense. So there's our addition line, and now we're ready to rock and roll. So I'll switch to green because I haven't used green, and we're going to head on down the way. What's our leading term? Our cubic term is not 13x cubed. It is negative 13x cubed. Negative 24x squared. Good job, you guys. And our linear term is plus 39x, and then just plus 8. Again, you're not going to go further than this because those terms can't go together. You guys feel like you got this?
Yeah.
It totally is. But again, as demonstrated during the lecture there, it's real easy to go off the rails. Just it happens without warning. So I will cut this out.